My name is Saurabh, and in today's video we will understand residual compensation factor for earth fault. So friend, in the last video we understood the distance protection relay setting calculation, where we saw that if we have positive sequence impedance, negative sequence impedance, zero sequence impedance, any length of transmission line, all these are provided. So how can we calculate zone 1 protection setting, zone 2, zone 3 in the relay? Friend, if we talk about practical, then if we have any protection, whether it is differential protection, distance protection, overcurrent protection, we cannot put theoretical value in the relay. If we directly put the theoretical value in the relay which we have calculated, then the relay can perform the malfunction. It can send wrong tripping command to the breaker. For example, if we look at differential protection, we have to consider city error, PT error, transformer losses, etc. And all these things have to be compensated. So the relay that sees the current, after seeing that current, compensates all those things, and the final current that we actually need should be shown by the relay. In the same way, if we talk about distance protection, then suppose there is a phase to ground fault here. So if there is a phase to ground fault, friend, then we know that the fault current in a phase to ground fault will pass through the ground. And wherever the transformer is earthed, the fault current will come through the loop again. So the data that we have entered in the relay, we also saw in the last video that the data that we have entered in the relay, that impedance, we have calculated the impedance of the line. That is Z1. But we have not calculated the earth impedance anywhere. But whenever there is a single line to ground fault or a phase to ground fault, the relay is also checking the ground impedance here. So the total impedance that is coming here is Z1, that means the line impedance plus the earth impedance, which we have not calculated till now. So if we do not compensate this earth impedance in the relay, then the relay will operate poorly. It will see the fault somewhere else. That means it will see Z1 plus Z, and we will call this overreach, that if the supposed fault occurs in zone 1, then the relay can see that the fault is in zone 2 and can send delayed tripping command to the breaker. So to overcome this, we calculate Z with respect to Z, not Z1, and we use it as a compensating factor in the relay. So friend, this is what we call Z because we do not know Z, so we can write this as ZT equals Z1 plus KZZ1. We have written Z in the form of KZZ1, where Kz is, this is what we call residual compensation factor. This is what we call KNK0. Wherever you see anything, friend, all mean the same. Different relays have different nomenclatures. So what is Kz? How will we calculate this? Let us first understand this a little, so it will be easy for you to understand how we actually put Kz in the relay and how we calculate it. So friend, we know ZT is nothing, but suppose a fault to ground fault has occurred, then it is VA, IA. This becomes equal to Z1 plus Z. Suppose this becomes my equation number 1. So friends, we know that VA, which is our phase voltage, is made up of 3 components. Positive sequence plus negative sequence plus zero sequence. So, we can write VA like this also. I1 Z1 plus I2 Z2 plus I naught Z0. Now friends, we know that in any transmission line, positive sequence impedance is equal to negative sequence impedance. So if we see it, we can write it like this: VA equals Z1 I1 plus I2 plus I naught Z0, because Z1 equals Z2, so we have taken Z1 common. You can see it here. Here we have taken Z1 common, so I1 plus I2 plus I naught Z0. Now VA equals, we will now make I naught Z1 plus minus. So Z1 I1 plus I2 plus I naught Z0. I naught Z1 we have made simple I naught Z1 negative and positive. Now I1 plus I2 plus I0, we can call this as I phase current or a phase current. Plus here if we take I0 common then we will get Z0 Z1. So friend, I hope you have understood till here. Now if you look at single phase to ground fault, then here IA is also made up of three components. I1 plus I2 plus I0. Now in single phase to ground fault I1 equals I2 equals I0. Because all the currents are in series. So all three currents will be equal. So we can also write it as IA equals 3I0. And we can also write it as I0 equals IA, 3. So here let us come to this equation. So here we can write VA equals Z1 IA plus I0 just now we calculated IA, 3 so IA, 3. ZZ1. So friends we can write it is VA, IA equals Z1 plus Z0 Z1 third, so this is VA, IA which we just saw. This VA, IA is nothing but ZT. Total impedance equals Z1 plus Z0 Z1 third Z1. Z1 we can write it like this also. Now friends this is our equation. I will write it here as well. ZT equals Z1 plus ZZ. 1/3 Z1. Z1 now look at this equation, and the first equation we made was ZT equals Z1 plus KZ asterisk Z1. The first equation we made was ZT equals Z1 plus KZ asterisk Z1. Now if we compare both of these then we will get here. Firstly KZ will be equal to ZZ 1/3 Z1. One more equation we got is that our compensating factor, this is what we call compensating factor. We will get one more equation that is Z1 equals ZT, 1 plus KZ. So friend what is the relay calculating for us? The relay was calculating our ZT. Just now we saw in the beginning here that the relay is calculating our ZT here. So what will the relay compensate? We will fix the value in KZ relay and the relay which will calculate the final Z1 as compensation will make it ZT, 1 plus KZ. So the relay will understand the impedance of actual zone 1. So friend, let us understand this with the same example. Here you can see that our positive sequence resistance reactance and zero sequence resistance reactance are given on the left side. So we calculate the compensating factor here. So you can see here that KZ0 is the residual compensation here. We have just calculated its Z0 Z1 third Z1. So here Z0 Z1 third Z1 and in that way we have to calculate the angle also. So the angle Z0 Z1 third Z1. So what is the Z0? Z0 is the zero sequence impedance. So, you can see the zero sequence here, friend 397 plus I 1.162. So, this is our zero sequence impedance. Minus Z1, so what is Z1? Positive sequence resistance, that is 164 plus I asterisk positive sequence reactance 394 so, here you can see it divided by 3 asterisk Z1. So, friend if you calculate it then your answer will be 627.27 angle 5.722. So, this is our compensating factor. So friend, I hope you must have understood that whenever we see distance protection, how we have to compensate the Earth impedance. How its derivation is calculated. So you must have also understood the example that how we have to compensate. So in the relay we put this value where there is provision to put kz or kn. So I hope you must have understood what is residual compensation for earth fault. So friend, that's all about this video. If you like the video, please like, share and subscribe. If you have any doubt, you can ask in the comment section. Thank you.